Okay, good morning. It's Malibongwe Mtila here speaking, learner from Maria High School, grade 11. And I've been part of the STEM club for 2 years now. We've been doing a lot of experiments, and what we have here today is a H2O clock, a water clock. And right here we have a brass electrode. The brass electrode is the brass colored one on the right hand side. And on this side we have the zinc electrode, and in the middle we have a plastic separator which separates the brass from the zinc electrode. And the first step is to assemble the pieces together. So the first thing I did, I put this cell with the brass electrode and the zinc electrode inside this plastic base, which is the black base. I put both of them in, and then the second thing I did is that I connected these two black and red wires. After I did that, I put in the two springs, the first spring and the second spring. And at the bottom you'll find that there are clamps which are used to lock in the springs to keep them from falling. And then the fourth step is to put in the watch. When you're putting in the watch, it's important to put the red wire at the back and the black wire in the front. After I did that, I pulled them up here. You can see that it's the red wire at the back and the black wire at the front, and then you push them up to the top where they can come out over here. And then you need to connect these two wires, the red two wires, which are going to serve as the positive charge of the terminal. And then you're going to have to connect them to the spring. And then secondly, you're going to have to connect the two black wires to serve as the negative charge. Okay, what you see here, what's going to happen is that the brass is going to produce the negative electrons, which are going to be flowing in. And then the silver is going to produce the positive electrons, which are going to flow out. So the current is going to flow out here, pass through the small clock, and then come back here. So it's just a flow of electricity. And then after you've done doing that, if it switches on, that means that everything is going okay, there are no mistakes. The electrons produced by the water are sufficient enough to make sure that it lights. But if it does not light up, that means the water is too pure and there are not enough electrons to make it light on. So what you're going to need to do is you're going to have to remove one of them, empty the water, and no, you're not going to have to empty the water. Just put a few drops of lemon juice, that to increase the quality of the electrons. So it's important that you do it to one of these. If you do it to both of them, you could end up producing a lot of electrons at a lot of volts and end up damaging the clock. So if you're going to do experiments, trying different substances, it's absolutely important that you use one of these. You could try soya sauce, ketchup, lemonade, whatever works, but make sure that you use only one of these, because it's only a 1.2 to 1.6 volt clock. So these is a 0.8 and a 0.8 volt, which make 1.6, which is very sufficient to keep the clock going. And what you have at the front over here, you have the reset button. If you see that the clock is not corresponding with your phone clock, you can just set it right there. First set the hours, and then you set the minutes, and everything is going okay. We can see there that everything is going fine, therefore there's no need for a reset. There we go. It's a very interesting and very beautiful circuit, and I'm happy to do more of these soon. Thank you.
Okay, great. So I have one more question. Okay, can you please disconnect it?
Okay.
Just disconnect the system so you can see.
Okay, when you disconnect the system, just this one, there it goes.
Oh yeah, that
So
means it
that
really
means-
works. Okay,
yeah.
please plug it again.
Okay, when you plug it in, there we go.
Perfect.
Yeah.
It's working perfectly. So what's the name of the system?
It's an H2O clock.
Or is it
So
H2O?
you'll never have to go and buy another battery for your watch. It runs forever.
Oh, okay, very interesting.
Yeah.
Thank you very much, Malibongwe.
Okay, so